Welcome to the homework of the machine learning. In here, practice lab, collaborating filtering recommender system. In this exercise, we will implement collaboration filtering to build a recommender system for movies. And notations, recommender systems, movie rating datasets, collaborating filter learning algorithm, collaborator filtering, and there's exercise one. Actually, there's only one exercise in here, and let's implement my stuff. I guess this was okay. This could be. I'm not sure. There are a lot of ML environment is activated. Um, ML. Uh, ML underscore environment is not here, but if I go for the ML, let me go to ML environment. No, sorry. Up. Sorry. I guess this was which I'm using. No, the name is okay. I'm gonna implement pandas, and I will restart the recording. Okay, so continue. I just imported my packages, and here's the notations. And for the recommender system, and okay, implementing the. I have to check my sound. Yeah, collaborative filtering learning algorithm and apply it to the dataset of moving ratings. The goal of collaborative filtering recommender system is to generate two vectors. For each user, a parameter vector that embodies the movie taste of a user. For each movie, a feature vector of the same size which embodies some description of the movie. The dot product of the two vector plus the bias term should produce an estimate of rating the user might give to the rating. And existing rating are provided in matrix format shown. U contains rating 0.5 to 5 inclusive in zero point 0.5 steps. 0 if the movie has not been rated. RA is where is this actually? Yeah, it's here. 0.25. 0 is not rated. Or as a one where movies have been rated. Movies are in rows, users in columns. Each has a parameter vector W user and bias. Each movie has a feature vector X movie. These vectors are simultaneously learned by using the existing user movie rating as training data. One training example is shown above. Weight one, actually this is a weight, the first weight, the first sample, and the first bias plot is equal to 4. I mean 1, 1, and plus b is the 4 in here, and all users, while the vector of the user must satisfy all the movies. This is the source of the name of this approach. All the users collaborate to generate the rating set. Once the feature vector parameter the learned, they can be used to predict how a user might rate an unrated movie. This is shown in the diagram above. The equation is the example of predicting a rating for user 1 on movie 0. In this exercise, you will implement the function coffee cost func that computes the collaborative filtering objective function. After implementing the objective function, you will use a TensorFlow custom training loop to learn the parameters for collaborating filter. The first step to detail the dataset and data structures that will be used in the lab. The movie rating dataset, and where's it been taken? And the dataset has 9K movies rated by 600 users. The dataset has been reduced to size focus on movies for the year since 2000. The dataset consists of rating on scale 0.5 to 5 in 0.5 step increment. The reduced dataset has number of users is 443 and number of movies are 400 4,778 movies. And load the movie dataset into the variables UNR, the matrix. So the ratings, the are binary value indicator matrix where okay, yeah. The ith row of x corresponds to the feature vector x for the ith movie, and ith row of w corresponds to one parameter vector v for the j, the user. Both x and w are dimensional vectors. For the purpose of the exercise, you will use n equals 10, and therefore x and w have 10 elements. Corresponding x is a number of movie times 10 metrics, and weight is a number of users times 10 metrics. We will start loading the movie rating dataset to understand the structure of the data. We're first loading the data in here is given the shapes in here and number features 10, number movies in here, and number users is here. Actually, I can show it in here like two. And in here, let me run it. NumPy mean are boolean. One average rating for movie is 3.4. And is this for the first one? Let me check it. Yes. Average rating for the movie one. Yeah, this is the one. This is the first one. For because we are taking the first element, u over t, and x over t and u over t actually, like this one. And collaborative filtering learning algorithm, and we'll begin implementing the collaborative filtering learning algorithm. Start by implementing the objective function. The collaborative filtering algorithm in the set of movie recommendation considers a set of n-dimensional parameter vectors where the model predicts the rating for movie I by user j as given a dataset that consists of a set of rating produced by some users on some movies. You wish to learn the parameter vectors that produce the best fit. You will complete the coding coffee cost function to complete the operative filtering and filtering cost function, the j of the filtering, and it's given here. And you should now write the coffee cost function. So basically, j coffee, the cost, and implementation is here. It's given the filters in here. Uh, First of all, I have to write. I have to this is a regularization part, but I have to find this one. This is J. all the j ones and v's plus b. So predicted. So I have to have the predicted value x v transpose times b, and I have to calculate the error. So error, and error will be equal predicted minus true value and times r, and it's returning to the j, so I have to use j in here to calculate it, and j is 1 divided 2, 1 divided 2, and summarization of all of them times by that. Oh, sorry, it was sum of all of them in here, and ijr to ij1. Okay, sum square root must be square root, isn't it? Yeah. Square root. Uh, I guess I miss. Oh, yeah, I put wrong in here. Must be here plus. Sorry. Error square root and plus lambda divided 2. Lambda divided 2. Divided 2 and rk over 2 square root 2 times numpy b square root. Let me see. B square root. Where I was. Yep. And x square root. Yeah. So square root plus numpy dot sum x square root 2. Let me run it. It's true. Well, actually, we can see it in here. Yeah, it's just true, and expected output is true. So evaluation cost function regularization in here, and sorry, all tests has been passed. Yeah, it's just simply the coffee cough. J after coffee is in here. In your learning movie recommendations, after you finish implementing the collaborative filtering cost function, you can start training your algorithm to make movie recommendation for yourself. In the cell below, you can enter your own movie choices. The algorithm recommended for you, and let me run this one. Mm, this is reloading. Prepare and optimization. It may take some times because now train the collaborative filtering model. This will learn parameters X, V, and B. The operation involves in learning WB and X simultaneously do not fall into the physical layers offered in the TensorFlow neural network package. Consequently, the flow used in course 2, model, compile, fit, predict, are not directly applicable. Instead, we can use a custom training loop. Recall from earlier labs the steps of gradient descent. Repeat until convergence, compute forward pass, compute the derivatives of the laws relative to parameters, update the parameters using the learning rate, and compute the derivatives. TensorFlow has a marvelous capability of calculating the derivatives for you. This is shown below. Within the TensorFlow gradient tape section, operations on TensorFlow variables I are tracked. When tape gradient is later called, it will return the gradient of the loss relative to the traced variables. The gradients can be applied to parameters using an optimizer. This is a very brief introduction to useful feature of TensorFlow and other machine learning frameworks. Further information can be found by investigation custom training loops with the frameworks of interest and recommendations. Below we computed rating for all the movies and users and display the movies that are recommended. These are based on the movies and rating integrated as my ratings above. To predict the rating of movie I for user J, you compute VJXI and plus BJ. This can be computed for all rating using matrix multiplication. And in practice, additional information can be utilized to enhance your prediction about the predicted rating for the 500 movies lie in a small range. We can augment the above by selecting from these top movies that have high average rating and movies with more than 20 ratings. The section uses a pandas data frame which has many handy sorting features, and we implement a useful recommender system. And thanks for the listening. Have a good day.